Hi, a viewer called Smegzgame sent me this to have a look at, and it's a Draper digital multimeter, and he sent a letter with it, and it says, "Hello, buy it, fix it. I hope this will be an interesting repair for you. Had a look at it myself, but I can't see anything wrong apart from the 10 amp fuse has blown a track, which I think was from when I used it to test a car battery. It was working fine until a few weeks ago, and when I went to use it, it had a dim backlight, which I thought was the battery. So hope you can find the problem. I don't need it back as I bought a new one." Right. So I'll just put these out of the way for now. It feels rather light and not the best quality, let's say. So let's see how you put the battery in. Let's try undoing that screw. Just grab a Phillips screwdriver. And that's the battery compartment there. Let's just zoom down a little bit. And it looks like that's the positive there. It's a little bit hard to make out. It's not really marked the best. Right, let's pop the battery in. And I'll just hold it up. Something rattling around inside of it there, I think. I'll just check those battery terminals because I feel a little bit slack. I'm just getting a straight screwdriver. Just try bending these out a little bit, just in case I'm not making proper contact. It doesn't seem to be doing much. I'll just check that battery's okay. I'll just zoom out a bit and get my meter in shot. I'll just go into volts DC. It's a little bit down, that battery. I'll see if I've got another one. Right, back with another battery. Let's try this one. Right, 9.1. Let's see if it does anything now then. Oh, I just... Right, well, when you turn it, we do get the backlight flash on for a brief moment. Or it was. And now it's not doing anything. Let's just check that battery again. Right, let's take it apart and have a look, see if we can see what's wrong with it. So I'll take those 4 screws here, let's remove those. Yeah, right, well that's not a good sign. Let's just zoom down a bit. It looks like the main IC here is a blob chip. So let's hope it's not that, because otherwise we'll not be able to repair this. And that must be the blown track that he's talking about. I can just see it down there. So if the fuse is okay, let's just measure that fuse. I'll just zoom back out a sec. I'll just go into continuity. Well, the fuse is okay. That track is definitely blown. You would have thought the fuse would have blown before the track, because that's the way it's supposed to work. But so that's one little issue with this, but I wouldn't have thought that would stop it from working. Let's just zoom back down again, see if we can see anything obvious. What's that? Something rolling around there. A little ball bearing. Let's put that down. for now. Oh, there's another one there. I just noticed there's another ball bearing here. I wonder if that's for the front dial, because it's not clicking. Normally you would get like a click when you go from like there to there sort of thing, but it's not doing that. You can actually set it in between. So I think those ball bearings must be off this rotary switch here at the front. Let's pull the board out, we'll have a look at the board, see what's on the other side of it. So I'll just grab a Phillips screwdriver, smaller one. There's another screw here. Let's see how this board comes out then. That was fairly straightforward. So that must be where those ball bearings go, where these springs are here. But again, that wouldn't stop it from working, so... Well, there's nothing really on this side of the board. I can't see any blown tracks or anything. I'll just zoom down a touch more. No signs of corrosion or anything. Well, I guess we better try some components. Try testing some components here. Must be the backlight. Let's just see if it's got anything to do with the display. I mean, that seems fairly secure. It's got little clips there. Well, what I might do is put this board back together with the little ball bearings in. We'll hook, this looks like where the power comes in, so we'll hook that up to the bench power supply, and then I might get the thermal camera on it, and we'll just see if there's a short or anything anywhere, or we'll see if this blob chip gets hot, because if that starts getting hot, if that's fried, well, like I said, pretty much game over, isn't it? So let's do that. So I'll see if I can pop these two little ball bearings back in first. Get this LED backlight back in. Just zoom out refraction. Let's try and keep this together so those springs and those ball bearings don't pop out. Let's see if it clicks now. That's better. That's that part sorted. So the positive was here. So that'll be the positive terminal there, and that'll be the negative. So let's hook the bench power supply up to it. I'll just zoom out a fraction. And I've got it set to 9 volts at 100 milliamp. Let's just see if it does anything different now. Let's switch the power supply on. I did see a brief flash there. It looked like one of the digits kind of lit up there and then just went there. I'd definitely seen a 1 there light up and then it just went off. Yeah. Right, let's get the thermal camera out. Let's leave like that for the moment. I'll just zoom out a fraction. I'll just switch the thermal camera on. And this is the Kowitz KTIW02. thermal camera. I mean, it's not on at the moment. I just thought I'd have a look over the board first. Let's try switching it on now. Right, look, we've got something getting warm there. Right, looks like that IC there. I'm not getting anything on the blob chip though. And it appears not. So I wonder if the fault is that IC there. And anything else getting hot? Let's just have a quick look. Nope, definitely that IC there. Right. Let's switch the thermal camera off. I think what I'll do, I'll bring the microscope in and we'll have a look at this IC here. Right, one moment please. Right, I've got the microscope set up and this is the TOMLOV 4K Autofocus Max microscope that I'm using. And I'll leave some links to this and other tools that I use in the video description. So this is a LM358 op amp. Right, so I think what I'll have to do is undo this board. We'll get the rework station out, we'll change this, and we'll see if that makes any difference. Well, I think while I've got the board out as well, I'll check some of these capacitors with the meter to see if any of those have got shorts, and I think we'll check those couple of transistors as well. Right, I've got the meter in shot, so let's just check these. Let's check this transistor. That seems okay. Let's try this one. That seems okay. Right, I'll get the rework station out and we'll take this chip off. Right, I'm just going to add a bit of flux. And then I'm going to put some leaded solder on here just to make it a little bit easier to get off. Just use the iron to put some leaded solder on here. Right, I'll get some hot air on that now. There we go, that came off nice and easy. Right, I've got a replacement chip that I've just pulled off an old board there. So we'll just try that one. Let's try and get it roughly in place. Just haven't got any new LM358s, so I'm just going to clean the end of my tweezers here. Should do. I'm just going to add a little bit more solder to these two pins here. Just put a little bit of flux on there first. Right, that's a bit better. Right, I'm just going to clean that up with a bit of IP and a toothbrush. Just use a cotton bud to clear up any excess flux that's left. Right, I'll get the microscope out of the way then. Right, so while we're on as well, we need to repair this track here. So let's take that fuse out and we'll just solder a wire from there to there. So I'll just get the iron out. I'm just going to go from this point here. I've got some of this solid tinned wire here. It's a little bit thick, but and then I'm just going to solder it to this point here. And get the soldering iron in. So if that cool down a second, I'll resolder this bit. Right, I'll just snip that off there. Right, I'll pop this fuse back in. And I'll just check that we're getting continuity. So let's go from this point here. Yes. Right. Let's see if we can pop it back together then. Looks like the wires came off for the backlight. I'll just solder that back on as well while we're on. So I've got no idea if this will work, but let's see what it does. Now I'm going to hook it up with the bench power supply again. There's the old chip I've just removed. And I still don't appear to be getting anything. Oh. Well, the backlight button's working now. I've still got nothing on the screen. Let's get the thermal camera out again. We'll just have a look. Well, that IC isn't getting hot anymore. Well, nothing appears to be getting hot now. But it must be processing because it's recognising the backlight switch. So I'm not too sure about this now then. Unless there's part of the blob chip blown. Right, we'll just disconnect the power supply for now. I'll switch that off. I mean, 100 milliamps should be. Let's just up the amperage slightly. Let's just go to 0.2. Just in case. Well, the beep function's working, apart from it thinks it's continuously on. So that's interesting. So I wonder if there's something on the input side, because it does seem like it's processing. Right, I'll just connect the power supply again. Just switch it off. Let's just zoom back down again. I mean, it looks like we've put some kind of resistor network here. That must be for the different selections. I didn't check that transistor there. And we've got another transistor there. And we've got a couple of diodes as well. Now, one thing I've just noticed, I wonder if these potentiometers have been played with, because it looks like that one is turned all the way one way and that one's turned all the way that way. It looks like they just turn round and round and round. So I wonder if that's got anything to do with it. Let's just try that. Just wondered if one of them's maybe like contrast or something, I don't know. It's just strange how there's nothing on the display, isn't it? And why it's continuously beeping. Right, we've got another transistor down here. I'll just zoom out, we'll try and get the meter in shot. Yeah. Right, I think that transistor's faulty. Or shorted. And it is an SS-8050, I think that is. Actually, I'm just looking there, it looks like those two legs joined together. Looks like those two legs are joined together there. Why would they do that? So I've got no idea what's going on there. But that is on the input side, because it's after those resistors. So I wonder if that's got something to do with it. I mean, it's definitely shorted by the look of things. Let's take that out. Let's take that out, and I think we'll check some other components on this board before we go any further. Because it seems like I've had this board in and out a few times now. Right, so that transistor's there. I'm just going to add a little bit of flux first. And I think I'll use the little engineer solder sucker. I think I still got a hold of it somewhere. Let's just test that. I actually think that's alright. I must have just been measuring other stuff in circuit. Yeah, that actually seems alright, that. So it's not that. Let's just try these diodes. That one's okay. Bit of a low reading on those two, but there might be other stuff. There might be other stuff in the circuit, you see. I'm getting the same value both way on those. So those could be faulty, or could just be measuring stuff in circuit. We've got a little surface mount transistor here as well. Well, I'm getting a reading that way, but I'm not getting anything there. But I am that way. Yeah, so that's probably okay as well then. So it's not looking good. Let's just try some of these capacitors just in case we've got a short. Let's go on to ohms. That one's fine. That one's fine. That one's fine. That one's fine. Well, all those are okay. So, it's not looking good. I think it could be this chip's failed or being blown up. I'll take those two diodes out just to double check them, but I think there's just components across them like these resistors and that and stuff, so I think that's why we're getting weird reads on those. Let's get that fuse out of the way. Tell you what, let's check that fuse. I didn't actually check that. Let's just see what that fuse measures. Yeah, the fuse is okay. So, not looking good on this one. I thought when I first seen the blob chip I was like a bit, Right, I'm just going to, actually I might use some low melt on these just to get them off. Right, I'll just go on to diode check. That one's okay. And that one's okay. Yeah. So the two diodes are okay. Like I say, we can't even look up the pin numbers on this chip because there's no number. It's just literally, it looks like there's a footprint for a chip. Like there. So sometimes they might have used a chip in a package, but this is just the bare die just straight onto the circuit board with a bit of blob of resin on top. That's why it's called a blob chip. I just thought I'd stick it under the microscope again just to check the connections going to the LCD display, just in case any of those are dirty. So I might just give those a bit of a clean with some IPA and just a bit kitchen roll, just in case. But I would have thought we would have gotten some segments on, even if there was a bad contact. You know, we'd have gotten some of the display segments lit up and possibly not others. I'm just seeing if there's anything I've missed. Yeah, that transistor's definitely bridged across on that side as well. So they must just be using that as a diode. It's a little bit strange, that. So what I've done is I've cleaned the zebra strip. I've checked to see if there's a polarizer missing or something by, you know, trying a different polarizer in front of it. And then I thought I'll get the scope out and I'll check to see if we're getting signals from this chip going to the connector on the LCD display. And unfortunately we're not getting anything out of this chip at all. There's just a constant voltage on pretty much every pin going to the display. There's no fluctuations when you turn the dial. So I'm 99% sure this blob chip has failed, unfortunately, or been damaged. So unfortunately this one's unrepairable. So I thought, just out of curiosity, would try and remove this blob chip just to have a look. So this is the underside of the die here. And you can see the bond wires where they broke off there, where I've just, obviously it just came off from the board there. You can just see them around the edges there. Let's try and find something to point with there. And you can see the little bond wires that are still embedded in this resin. And that's the underside of the actual silicon die, or the microchip there. And on the top of that you'd actually be able to see the actual circuit. I don't know if I'll be able to get it down to that far. I could try. There we can see actually a bit of the microchip there. Let's see if we can zoom down a bit more on that. Let's see if I can focus it in a bit better. So you can actually see part of the microchip there. I just thought you might find that a little bit interesting, that was all. So unfortunately no fix on this one. Like I said, you wouldn't be able to repair this because there wasn't any clock pulses when I measured on here, where it's got COSC and ROSC. So they should be the oscillator for the chip. There wasn't any oscillations on there. There wasn't any signals going to the LCD display. This chip was just completely dead. And I think what this op amp does over here, I think that's what generates the beep for the buzz, and I think it also controls the backlight, which is just pretty much a button and a capacitor circuit. So you press the button, the capacitor charges up, and then when the capacitor's discharged, it switches the backlight off, and I think that's it. So I thought it was actually controlled by the microcontroller at first, but I guess not. And he also checked all of the resistors on the board, all of those measured okay. I checked all the capacitors for shorts. So the only thing that was left was this. Like I said, I didn't have a good feeling from this one from the start, but it is what it is. So I actually managed to get the whole microchip die out without breaking it. And we can see all the different parts of the chip there. And you can see the size of it compared to my tweezers here. So we've got all different blocks of things. I don't know what they are. Some of that might be memory, some of it might be ROM or something. And some of it might just be logic. And I managed to get an even closer view of it. Almost looks like a top-down view of a little city or something. With little swimming pools and that and stuff in it. You can see where all the bond wires went around the edges to the big pads. And then it looks like we've got a lot of logic and stuff in the middle there. I don't know what that part is there. It looks like possibly even some writing there on the little green part. Just in the middle of the screen there. I just thought you might find that interesting. Right, so unfortunately this one's not repairable. Right then, if you enjoyed this video, please give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.